All right, thank you, Jacob. So this talk is actually listed under the philosophical track, but it's really like a technical exploration of like what I've been looking into the last little while. It just didn't fit neatly into any of the other tracks of this conference. So yeah, I've been looking into like dapps. We've been talking about them since the existence of our ecosystem and how we make them actually decentralized. So first, let's just have a look at what the ecosystem looks like right now. And in general, like I think most people tend to agree that censorship resistance is a core value to our community. And in general, for our core protocols, we always strive to maintain this property, and often we're doing not too bad on that, at least in the core protocols. But what about the applications that we're building? Well, of course, the smart contracts that we're building, they inherit the security and censorship resistance of the blockchains that are deployed on. But in my experience, only probably less than 1 to 2% of Ethereum applications are deployed with a decentralized frontend. And so the rest of the talk is going to be focused on the Ethereum ecosystem specifically, but the same principles apply to other blockchain ecosystems as well. So what happened? Why are we not decentralizing the front ends of our decentralized applications? Well, we actually known how to do this for a long while. I remember when I first got involved in the Ethereum community back in 2014, 2015, like it was just like well known and obvious that you deploy your front end on IPFS and then you sort of get this nice property. But it turned out that like doing that correctly isn't really trivial. There was like a lot of nuances there. And really the developers that had the expertise and understood how to do this well, they were often very technical, and they sort of ended up working as core protocol developers on various different crypto protocols, and myself included actually for the last several years I've been doing that. And so a lot of applications ended up sort of hiring front-end developers that might not have this experience and knowledge and wanted to move fast, and then we sort of forgot about decentralizing the front end. Another thing that happened was, of course, the whole Tornado Cash saga. Tornado Cash had a decentralized front end, and a lot of other DeFi projects had as well. But when the sanctions came on Tornado Cash, a lot of DeFi protocols sort of got cold feet and removed them or stopped maintaining them, which is really sad for our users. And it might not be the best thing for the DeFi protocols either in the long term. So why is this important, right? Like the first and obvious thing is censorship. And censorship is actually a growing problem. We see more tendency of it in Europe, maybe some in the US as well. Of course, in the East, there's a lot of censorship. This graph is actually from earlier this year. It's like, is there internet censorship? But it's actually not only like a problem in the East, right? Like in the West, we have blocking happening. And so this is what happened with the Pirate Bay. They're actually blocked in most of Western Europe and partially blocked in the US. So we have this problem globally, and we should really aim to serve users globally and avoid censorship globally. The other thing that's really important that censorship resistance affords us is security. So with DNS today, we sort of have a lot of trust vectors. So we have to trust the certificate roots that are sort of signing all the sessions that we make between the browser and the server. Then we have to trust the cloud server to do the right thing. Then we have to trust the developers of the website to have like appropriate operational security and not mess things up. And so, for example, my understanding of what happened in the Bybit hack was that some developer laptop got compromised, and the attacker was able to upload some malicious code to an S3 bucket, and that's served code. And of course, like TLS certificate and everything seemed fine, but the server was like served something they wasn't supposed to. So there's like a breakdown of the operational security and like the trust in the cloud server. So let's actually take the time and care about our users. Something I've heard around the ecosystem over the years, like smart contracts is the only thing that matters. As long as our smart contracts are decentralized and censorship resistant, there's always a fallback. But I think this is really not true. And it's really only true for experts that know how to use Etherscan or know how to use like specialized developer tools to interact with smart contracts. And most users don't know this. The only way they know how to access your application is through your front end. And if that front end is removed for some reason, they can't access it, then they're not going to be able to circumvent censorship or access this in case like the developer of the application disappears. So we need to do a lot better here. So what can we actually do to practically decentralize our frontends? I like to break this problem into 3 different components. So at the bottom, we have control, which basically is like, what is the process for how new versions of your application gets published, and how do we ensure the integrity of that? On top of that, we have integrity. So that's the integrity of the application itself. How do I, as a user, know that when I fetch the latest version of the application, I actually get the application that I'm supposed to be getting and not some other malicious code? Finally, we have networking. So that's basically when I have the application, it's very likely gonna want to access some networking resources. So the most obvious example is that we want to read state from the blockchain. We want to be able to send transactions to the network, and maybe we want to do something else like monitoring and seeing like how well adopted the application is. So let's talk about these each in detail. So first we have control. Right now, like most frontends are hosted with DNS and a server. DNS, the security there is basically set an IP address, and the server whose IP address you set basically handles the authentication, and we have all the problems I mentioned before. My recommendation is just move to an on-chain naming system like ENS. So with ENS, we set the content hash, basically the fingerprint of your application. And this ensures, later we'll talk about this more in integrity, ensures that you get the right version of your application. This can be controlled by multisig, or we can even add custom logic like time locks or anything else that might be relevant for your application. But I think one of the really big benefits here is that we can have on-chain, auditable, verifiable version history of how the application has changed over time. That's something we don't really have in DNS because the server can just arbitrarily change the code that is deployed. The other thing is ENS is well supported. There's a wide ecosystem of tools for like trading the domains, but also to like use them in various applications. And most importantly of that is that there's a lot of mirrors for accessing content on ENS. When you publish an ENS website, you can access this through all of these mirrors. And there might be more that I'm not listing here, but if one of these mirrors were to go down, you can also go to a different one. So this is really useful. Next, we get to integrity. So this is all about how you distribute your application. So ENS itself supports multiple different protocols in its content hash system. My recommendation is just kind of to use IPFS. It's the most well-supported and well-adopted protocol that we have out for this right now. There's no token or weird incentives that might, want to distribute the token to your users or to the developers of the application. So it's neutral in that sense. You can replicate the website locally. You can even export data in IPFS to an archive file that you can, ship around on a USB drive. And it's quite easy to do. So like that's a huge advantage in my opinion. When using IPFS, I would really urge you to avoid IPNS. So IPNS is basically instead of publishing the hash of your site, you publish a public key. And then off-chain, that public key or the private key of that public key can sign updates of like what is the current thing that's pointing at. And we lose all the on-chain auditability that we had with DNS. And I think that's really just like replacing DNS with something that's like slightly better, but doesn't really provide the nice guarantees we get from the blockchain. Additionally, we want to really protect the integrity of all the resources we're distributing in our front end. So first of all, only use static builds. I think this should go without saying, but don't do any server-side rendering. Server-side rendering implies that you have a server, right? Bundle all the resources of your application within, so what that means is like, don't load scripts from other sites. Don't load fonts from Google, right? Like I see this in a lot of applications, they just load fonts from Google, and that, if they decide to remove them, maybe that's bad for your application's uptime, but also that compromises the privacy of your users. So generally the same thing applies with media, like pictures and videos and stuff like this. Basically, everything that's when your user loads the page should come from the folder which you add to IPFS and put into the content hash on ENS. An additional security step you can do is use something called sub-resource integrity. So in HTML, there's this thing you can add in script and link tags that's called integrity, where you can put the hash of the thing you're loading. And so if everything is loaded natively from like ENS and IPFS, you don't really need this. But in most cases, when you use these like mirrors for ENS names, like these gateways, you kind of have to trust as a user. But if we add this integrity check, it basically means that when you load the resources underneath, the browser automatically checks the hash of these things. So that's a good additional security measure we can add. All right, finally, we get to networking. I like to think of this as like the runtime security of your application. So most likely, when you're building an app, unless you're building some really simple note-taking app, you're going to want to access blockchain data. You're going to want to send transactions, and you're likely going to want to gather metrics about how your application is being used. And so how do you do this? Also, I like to split this into 4 categories: the Ethereum node RPC, the user operation bundle, or EIP 4337, and then an indexer that deals with different ways of querying the data and potentially user data, and then auxiliary services. So I'll go through each of these and like how we can make these maximally censorship resistant when you're building and deploying your application. So the Ethereum node RPC is, of course, the most commoditized of the services that you're going to have to use in your application. And the ideal state here is like, you don't go to a provider and pay for an RPC. Like ideally, we can run a light client in the browser. We're pretty far away from doing that still. The recommendations I have right now is use window.ethereum when it's available. It might have like user configured RPCs and stuff. It's just a nice thing to do. But also provide redundant endpoints. So don't just have like one RPC provider, have multiple in case one of them were to disappear for some reason or not be accessible. But finally, I think it's important that we add something I'm calling like an override. So an override is basically a query parameter that you put on, you can put into the URL bar that specifies for a particular chain ID, you specify an RPC URL. And that allows your users to override the RPCs that you have configured in your application in case like all of them are down. Then basically users have a backup option in case like in the future you stop paying for your RPC endpoints and they still want to use your application. For the EIP 4337 user op bundler, basically the same thing applies. It's a service you pay for in many cases. The ideal state is actually slightly different. Ideally, we can have a peer-to-peer access to the bundler mempool in the browser. I've done a little bit of looking into this. It seems like it might be possible. Just some infrastructure changes and some JavaScript development needs to happen, but we're not there yet. So again, provide multiple redundant endpoints and support overrides in the same way I described for the RPC endpoints. All right, the next thing is sort of a concept I made up, which is called deservice. And so this is the realization that you're likely going to need some sort of indexing over blockchain data. For example, if you have an NFT, you can't just access a set of users and all of their balances for that NFT by going to the Ethereum RPC. You need some indexer where you can more conveniently query the data. And you might also need to like synchronize some off-chain data. For example, an NFT might have a content hash in its token URL that points to like some IPFS content. And so this is by far the riskiest centralization vector of your application. And you don't want to end up in a situation where the applications you're using just like have one centralized indexer that if it goes down, the application stops working. So what I would recommend is build something that's open source and that's easy to deploy. And it's important that this thing you build is eventually consistent. So anyone that spins up a version of this service can look at the blockchain, potentially connect to content addressed networks and synchronize data and get to the same state as all the other similar nodes in existence. And then just same thing goes as the other services, provide redundant endpoints, ideally in different geographical regions, and provide the override. So maybe not every user might be able to like spin up their node and provide an override, but if your application in the future goes you stop running the service, the community might come together and spin up this open source service and continue operating the application without any changes needed to the code. And I think the D-service framework is actually like quite interesting because it could enable like an ecosystem of these services to work between decentralized applications, and potentially like you could have like on-chain payments between them. So it could be a revenue source for dapps. But important to note here is there's no vendor lock-in, right? Like you could have your own custom implementation. You could rely on like maybe some restaking protocol, or you could use a generic indexer, as long as anyone could spin up a node and index the same stuff. All right, last but and actually hopefully least is the auxiliary services. So this is basically anything else that I haven't mentioned so far. And the key thing here is that your application should continue operating. The core functionality of your app should work, even if all these endpoints are down. So this might be like non-critical features, might be some analytics to better understand the adoption of your application. It might be something like Wallet Connect that like relays traffic to like a phone through some relay. But yeah, the most important thing of these auxiliary services is that if they're gone, your application should still function. So this might be like more centralized things, right? And so with all of that, I think we're actually ready to start building more decentralized applications in general. And so let's make this a praxis when we're building applications. I've started a discussion on the ETH Magicians Forum for an ERC, best practices for dapps, or dappspic for short. It includes all the things I've talked about so far. And it also provides some more detail and nuances of like how we should do this. So have a look at that. Maybe comment and come up with improvements, but try to conform to it when you're building your dApp, and maybe build tools to help others make this more easy, because right now it's still like not the simplest thing to build in this way. Then I've also built a little dApp as well that benchmarks other applications based on how censorship resistant they are. So it's called DAppRank. You can find it dapprank.eth.link. And it provides like a detailed analysis of different applications on the integrity part, so like how well the distribution of the application happens. The networking part, are they fetching a bunch of data from endpoints that are centralized, or are they just like accessing RPC endpoints? Next, I want to add control. So like, is there a smart contract that governs the update of the application? And maybe there's even room in the future for stages, similar to how L2 B2 stages for L2s. So yeah, I think we're close to actually having a quite resilient dApp ecosystem. And so let's collaborate to build more dApps in this way. Thank you. Okay, so I read the question, or do you want to? I think you can just read. Actually, can you read it?
Yeah, okay, for sure. All right, we'll do a couple of questions. How decentralized is your dApp if it relies on trusted and centralized RPC endpoints?
Yeah, I mean, if you only rely on one of them, it's not very good. It's really bad. That's why, like, ideally you rely on, you have the window.ethereum thing, you have redundant endpoints. I mean, ideally there's also things like Helios, which is like a Rust library you can stick around your RPC endpoints that basically makes your RPC endpoints into like a light client, or at least it verifies the state proofs of every RPC call that you make. So try to do that as well.
Cool. Then we have one: for a website to live forever on IPFS, it requires running your own node or using centralized third parties, which offers pinning for payments. Is there a solution, I guess, for keeping it running forever without running your own node? Maybe that's a question.
Yeah, I mean, there are, as mentioned here, like, different providers that pin stuff on IPFS. I mean, running your own node just makes it more resilient. Actually, on DAppRank, I've listed a bunch of applications that are hosted on IPFS, and it lists, the number of seeders for each application. But yeah, I think there's definitely room for better incentivizations protocols on top of IPFS. I think Filecoin kind of didn't really get all the way to incentivizing availability of IPFS data. So maybe there's room for other protocols to like do that in a better way.
All right. What to do when we move from traditional front ends towards a crypto ChatGPT execution for transaction initiation? How can we make that front end secure?
Yeah, I mean, in general, with LLMs, I guess it's the question of like, should I outsource my inference to like a big model that's run in the cloud somewhere? Or, I mean, more ideally, we can have smaller models that work locally, that just like is more domain specific. And so I'm at least like for that type of application, I'm hoping for smaller models we can run locally to do the things we need to do. But it's hard to answer the question in completely in general.
Cool. I think the next two questions, they're from the same person, so just do it in one. How much worse would you say the UX is if you follow all these practices, so I guess for the user? And why do you think developers or people don't follow these practices?
Okay, yeah, I think this is a great question. So UX in terms of like, if you compare it to a Web 2 application, it might be worse. UX in terms of compared to other Web 3 applications that are hosted on a centralized frontend, I don't think it needs to be like that much worse. Maybe the worst part of it is that you need to type like .link after .eth or like .limo. But besides that, like I don't, and you can even have on your normal domain redirect to like a .eth domain. Besides that, I don't really think there's much of a drawback if you implement this well. It can look pretty much the same as before. Why don't people follow this now? Well, I think there's historical reasons. What I mentioned, like DeFi protocols were trying to go this way, and then sort of they got cold feet. So I think that's part of it. Like there was like a shilling effect that happened a while back. I think the other part is like it's harder to make this work. People, front-end developers are used to having like server-side rendering and stuff like that. That is convenient for people to build, but we can build pretty much like similar experience with these types of applications. So I think it's just like a knowledge and experience problem right now.
Cool. I think we can do. Why are light clients not there yet?
Well, I mean, I can tell you what problems exist to the extent of my knowledge, but especially in the browser, if I want a light client, where do I get the sort of state from? I think there was an effort in the Ethereum Foundation to like make a network to like distribute state. I don't know where that effort is right now, but you need to sort of distribute the blockchain state for a light client to work. And as far as I understand, that wasn't really something that was easy to access from the browser. But again, I think something like Helios, which is basically a wrapper around an RPC endpoint, can give you closer to a light client experience where you can rely on an RPC endpoint without having to trust it, right? So you verify the header chain of the beacon chain, and then you verify for every RPC call you make, you verify the state proof, but you're not like fully peer-to-peer synchronizing the state you need. So I think that's a decent trade-off.
All right, I think we can do one more. How do you see the balance between censorship resistance and security? For example, with giving users RPC override, but users provide a malicious RPC that tricks the user?
Yeah, this is a good question because it actually came up in the ETH Magicians forum post. It's a tricky thing, yeah. I think we are discussing right now, like, should the override take #1 priority over everything else? Or should it be more like a fallback? Or should it be somewhere in between? So maybe like the window.ethereum takes precedent, and then like your RPC endpoints comes after the override. But that's like an open discussion, actually. So like if you have thoughts and opinions about that, please go and find the forum post and we can talk more about it.